Namaskar, Srinivasa Ramanujan, a well-known name which gave pride to India in the field of mathematics. He is compared with all-time greats like Euler, Gauss and Jacobi. Friends, in order to discuss about the life and work of Ramanujan, we are here having in our studios Professor Dhruv Rana, who is from Jawaharlal Nehru University and is in the School of Social Sciences in Zakir Hussain Center for Educational Studies, and he did his master's degree in physics from IIT Mumbai and his research in philosophy of sciences, his PhD in philosophy of sciences from Gothenburg University. His major research is in the field of history, philosophy and sociology of science with a special reference to modern India. He authored and edited many books in this field. To discuss about the life and works of modern mathematician from India, that is Srinivasa Ramanujan, we have with us here in studio Shri T. Venkateswaran ji, and he is a scientist from Vigyan Prasar and is science communicator, science educator and science presenter also. Venkateswaran ji, will you start the discussion?
Yeah. Actually, it's a very important occasion. This December 22nd of 2008 is the 121st birth anniversary of Srinivasa Ramanujan. See, when he was born, for about 3 years he had difficulty in speaking. So the family was very worried. They were worried that whether this child will actually speak, whether this child is a retarded child. Of course, we know today that he is not at all a retarded child, but one can say that one of the famous mathematicians of the world, I mean, as you are rightly put it. When he studied in his school, I mean, of course, the family shifted to Kumbakonam, another place in Tamil Nadu. That's where he did most of his schooling. When he was studying in school, in the earlier classes, in the primary classes, there is a very interesting anecdote. See, the teacher was teaching division.
Right.
And the teacher wanted to make the students understand the division, so the teacher was using an analogy. So the teacher asked question that, see, suppose if I have 3 bananas and there are 3 people, I give each of them one banana, how much everybody will get? Okay, equally divided, right. Then how much everybody will get? Of course, the answer is 1.
Right.
Then the teacher asked that, suppose if I have 1000 bananas and there are 1000 children, and divided equally, how will I get? What will each fellow will get? Okay, the answer is also 1. Of course, we know that A by A is 1. But Ramanujan is not us, right? So even at that young age, he stood up and asked, sir, suppose if I have 0 bananas and there are 0 people, how much everybody will get?
Obviously not 1.
Yeah, you are correct. A by A is 1.
Right.
When A is not equal to 0.
Right.
But when 0 by 0, that is A by A and A is equal to 0, what value it is has been a great debate for quite a long time in the history of mathematics. You know, some people say that it's 0.
Right.
0 by 0 is 0. Some people say that no, 0 by 0 is infinity.
Right.
You know, I mean, there have been lots of argument. And this question was asked by a very ordinary, simple student, Ramanujan, in that very young age when he was studying in elementary schooling. One good thing is that teacher did not discourage him.
Right.
The teacher told him that when all the other students laughed, teacher told that he has asked a very interesting question. Of course, the teacher gave the answer that it's infinity, but that's a different matter. But right. There was encouragement from teacher. I think that's a very important point that we should
for
note.
Teachers particularly.
Yeah. While he was very studious in maths and he was well performing in maths, unfortunately he did not pay attention to other subjects. So in his academic records, he had quite a lot of problem. In fact, when he finished his school and when he wanted to join what in those days were called as FA, I mean, that is once you finish high school, I mean, you join FA before you join degree, he wanted to write a scholarship exam. Unfortunately, because he did not get enough marks in English, he was 3 marks less, okay, though he was the top mark in maths. Right. In fact, he was a district first in thing. But still, he couldn't get the scholarship, and he had to try it once again before he could get scholarship, and then he moved on. In fact, his whole studies on this FA is itself a very interesting thing, and I would like to ask Dhruv Rena to say something about that.
Yeah, you know, actually, Ramanujan is such an enigmatic figure, because he never really trained as an expert mathematician in some sense, and yet his contributions to mathematics have been so profound. The two books he read were actually textbooks. One was a book by Loney on trigonometry, and the other one was a book of Carey's, which basically was a book which contained about 800 theorems, and these theorems were not even proved. But based upon these two works, actually more on the latter work than the former, Ramanujan would embark on a journey which comprised generating a whole host of new theorems, as well as reinventing for himself a large number of older theorems which he had discovered for himself.
Yeah,
You know, and as Venkateshwaran was saying, he did well in college in maths. He did, I mean, brilliantly, but he failed because he was so obsessively involved in generating new knowledge and new theorems which went into his textbook, that he had to be given a second chance. And I don't think he fared particularly well, given that he had to study subjects like English and a number of other subjects. I don't think he fared particularly well the second time around. But before we go on to say something about what happened subsequently, I think it is important to realize that during all this period, he continued to be supported by his mother, his family, his friends, who recognized that there was something absolutely special about this person. And without this, I don't think Ramanujan could have reached where he did reach. Just imagine a child who is gifted continues to fail at examinations while he excels in mathematics. At some point, the family could have said, well, we don't support you any longer, you do something else.
Right.
No, that was not the case. I mean, people felt, particularly his mother, that there was a larger destiny waiting for him out there. And so, at this point, he begins to be introduced to a new circle of mathematicians. The Indian Mathematical Association is set up. There are people like Sheshu Iyer, and very important person in the figure of Narayana Rao.
When Mr. Narayana Iyer went through the notes written by Ramanujan, and he asked him to write down some few more steps within the 2 steps which Ramanujan has given. So because he was not able to understand, he said that I am a good mathematician, even I am not able to understand how a student or a ordinary teacher can understand. And then Ramanujan said that oh, these are very simple, why should I give many more steps within the 2 steps? So this is another very interesting thing about Ramanujan.
see, after he finishes his FA, I mean, because of the family situation, as I said, it was a very poor family with not much means. He is forced to take a job. I mean, many people, his friends, the mathematical friends, tell him that we will support you, and they used to even send money to him, about 12 rupees. In those days, it's a big amount.
Right.
They used to send him for his support, but he felt it was not a good thing to do, and then finally he joined as a clerk in Madras Port Trust. Okay, and while he was doing his work, in the spare time he used to do mathematics. Here I am reminded of Einstein, another great personality of 20th century. Even Einstein did all his path-breaking work, you know, all his foundation of relativity and various things, while he was working as a clerk in a patent office. It's a very interesting thing to note. I mean, there is that kind of a comparison. And while he was in Port Trust, I mean, the Port Trust chairman accidentally finds that he is also a mathematician. So he tells him that from tomorrow you don't have to do the clerical work. I'll give you a place, I'll give you a table. Right. You sit there and do maths and show it to me regularly that you are doing.
We land up in a situation where this clerk working in a port trust is suddenly recognized by the community of mathematicians in what used to be called the city of Madras, as well as a number of colonial officials who have come to know him. and say that this looks like the work of a genius. This man is not a crank. And so they encourage him to send his work to mathematicians. He is first encouraged by an English mathematician in Madras, but later subsequently he sends his work to two mathematicians at Cambridge. Neither of them reply. And in a recent novel by David Leavitt, which tries to reconstruct the atmosphere of Cambridge at the time, we begin to see why the mathematicians probably did not respond to Ramanujan's work. But he doesn't give up hope. He sends the text again to the renowned number theorist, but somebody working more in analysis than number theory, the renowned mathematician at Cambridge, G.H. Hardy. And we have Hardy's account of how he responded to that letter in his famous autobiography called The Mathematician's Apology. And Hardy tells us, I mean, it's also discussed by the well-known science writer C.P. Snow. Hardy tells us that when the book arrived, Ramanujan's letter arrived and his formulas arrived, he felt initially that it was the work of, as he says, a crank, and he put the book away. But something kept on coming back to him repeatedly, and what kept on coming back to him was that there were formulas there which revealed that this was probably the mind of a genius working.
Right.
And then he went to England, and then in England he joined Cambridge University.
Right.
The money was given by Hardy. The application money and the form was filled, and the money was paid for his tuition fees by Hardy.
Yeah, the relationship between Hardy and Ramanujan is a truly interesting one, and it's been deeply studied by renowned Indian scholars such as Ashish Nandi and a number of people. It was a rather interesting a relationship. Now here, Hardy has often said that he somehow wished that Ramanujan had been trained as a mathematician, so that maybe they could have got more out of him. But then he backpedals and says, but if he had been trained as a mathematician, he would have been less of a Ramanujan. Okay,
That's a
Right.
that's a
So
puzzle.
that genus will,
yeah, so that he would have been a typical European professor. Now Hardy was somebody who used to rate mathematicians on different scales. If he would put a scale of 1 to 100, he himself, and it tells you about Hardy's modesty, he himself would be at about 25 or so, and Littlewood would be at about maybe 40 or thereabouts. The great German mathematician David Hilbert would be close to 80, but Ramanujan would be at 100.
100
So
out of
nice.
100.
Yeah, so I think he was being very modest about it, and in later life he said, yeah, there was a certain kind of sentimentalism in those remarks. But the important point is that while Ramanujan is always seen as somebody who was pulling theorems out of his head, he always said, although Hardy believes he didn't really believe it, that it was the goddess Namagiri who inspired him into producing these theorems. Somebody who's worked on Ramanujan's notebooks, particularly Bruce Brent and others, believed that that was not the case. That Ramanujan was used to working with slate and chalk, and he could. They don't normally take his stories about divine inspiration very seriously, although they do recognize that there was a certain style of his functioning, and that style of his functioning was, he was somebody who could sort of visualize continued fractions and infinite series very rapidly. And then amongst his notebooks which he sent, the first set of equations which he sent Hardy, there's a series which goes by 1 plus 2 plus 3 plus 4, which he says this infinite series converges to minus 1 by 12.
12.
All right. Now the thing is, it appears as a very counterintuitive result, but then Ramanujan would write the series as 1 plus 2 to the power of minus 1 plus 3 to the power of minus 1, etc. So he definitely had his own style and another way of working with his equations. Would you like to add something
Actually,
to that?
if you look at, there is a very interesting thing, again kind of an anecdote. See, while he was in England, the climate did not suit him. He became very ill and he was admitted to a hospital. And while he was confined in hospital, Hardy came to visit him one day. I mean, it's a very famous thing that everyone talks about. Hardy comes in to cheer him up, says that, see, I came by a car whose number is 1729, 1729. And he said that, see, I think it's a product of 3 odd primes. I mean, he says that it's a product of 3 odd primes. Then Ramanujan holds back for a second and immediately replies, no, it has a very interesting property. It is the smallest number that can be written in the form of sum of 2 cubes. Okay. In fact, today that class of numbers, that is numbers which can be written as sum of 2 cubes, are called as taxi cab numbers.
Somebody who was working in what used to be called number theory, the theory which deals with the properties of numbers. But Hardy was somebody who was interested in something much bigger than that, something which was called analysis. And so the time Ramanujan spent with Hardy was not just spent in trying to establish some of the new results that Ramanujan had arrived at, but was also spent in doing some work in analysis. I mean, in developing a whole host of fields which we can enumerate, which we can list for you, but these are subsequent developments that come out of his work, and which Ramanujan himself was not directly associated with, but were outcomes of his work in number theory and analysis with Littlewood and Hardy, the theory of partition functions. And so you begin to see that he came up with some absolutely insightful ones, which were later developed into a whole host of new sets of mathematical subdisciplines between number theory and algebraic geometry and modular functions and a whole host of fields. And so I think Ramanujan's work has not in some sense lost its relevance. But before we come to that, just a minor story, that while he was in England, he also sort of worked with, while he was doing his work, I mean, we are all told that because of his vegetarianism, he was very ill. I mean, he fell ill, and that he probably developed tuberculosis. Over this, there's been some controversy of late, and some people say that basically it was an old amoebic hepatitis, which was playing up again, that led to the deterioration of his health, and he had to come back.
Because of his primary passion to mathematics, someone say that he did not give proper care to his health, and that's why we lost a very good mathematician at a very early stage. And probably if he would have been lived for longer time, we would have more mathematics, but otherwise we left something, we missed something. In your concluding remarks, I like to know from you some works where our viewers can have more information about Ramanujan and about his last days, and your concluding remarks.
Yeah, they've been, it's a kind of question which historians of science nowadays, which historians are rather scared about asking. I mean, we call them counterfactuals. Had he lived, what would have happened? You can never know. But that he lived so long, and the legacy and the mathematics he left behind, I mean, continues to inspire the work of so many physicists and so many mathematicians. They still find exciting results in his work. His work has found, some of his formulas and have found applications in fields of physics like statistical mechanics and other fields. And so, no, I mean, there is still a Ramanujan sort of industry going on. I mean, mathematicians like Bruce Brent have spent already more than 20 years working on his mathematical notebooks. All right, I mean, some of his notebooks contain about 3,400 formulae, and Some of them were known in his time, some of them were not known in his time, and the work continues. But for those of you, your viewers who wish to know more about Ramanujan, there's some very, very interesting biographies on Ramanujan. For example, Robert Canigal's biography was
The Man Who Knew Infinity.
Yeah, The Man Who Knew Infinity is an eminently readable piece of work.
So friends, we had a very interesting discussion on Ramanujan and his works, and this was just a initiation of this discussion, and probably if you not know more about Ramanujan, certainly this discussion will ignite your interest about Ramanujan, and many works has been mentioned by Professor Rana and Venkateswaran ji about Ramanujan, where you can have more information about him. And friends, on this day, that is the birth anniversary of Ramanujan, let us pay our homage to the great Indian mathematician of 20th century who gave pride to our country. So in the end, I must pay my thanks to Professor Rana and to Dr. Venkateswaran, who spared time to discuss about Ramanujan. Thank you very much, friends.